So this is grade 8, course 3, and it's we are learning geometry there. We are learning transformations like reflection, rotation, and sliding. So in previous classes, we discussed about this. Now, this is a practice test before your actual test in the school, and I'm trying to put some challenging problems. You can try on your own and then see the solutions if you have any difficulty. If you have difficulty still, please feel free to text me. So the first question is given the point A, 2, 3, and then we have to apply three transformations in order. First, reflect point A across y-axis to create point B. Normally in the test, they will ask A dash and A double dash, but to be more clear, I have written B and C. Otherwise, in the test, it would be A prime and A double prime. And the B is rotate point B 90-degree clockwise about the origin to create point C. And then third is translate point C using rule x y is changed to x plus 4 y minus 5. So first is the reflection, second is the rotation, and third is the translation. So it's not very difficult. Just be cautious about the addition or the transformation or the negative signs. So you can stop here and try on your own and then check the results. So reflection across y-axis means this is the y-axis. So suppose this is the point uh, 2, 3. So reflection means only x-axis, x coordinates changes. So it becomes negative 2, 3. So this is A and this is B. So in reflection, x coordinate changes. In reflection across y-axis, x coordinate changes the sign. So this is the B we got. Now it is rotate point B 90-degree clockwise or about the origin. So in the last class we learned the concept, and 90-degree clockwise means minus 90-degree, okay, and or 270-degree counterclockwise. It's the same thing. So we use the formula xy changes to y minus x. The rule here is y changes to y minus x for 90-degree clockwise about the origin. So b negative 2, 3 changes to c 3, 2. So now is the translation, which will change x to x plus 4 and y to y minus 5. So now in C, it was 3, 2, and we got D as 7 minus 3. So we started with the point 2, 3 here and ended with D, which is 7 minus 3. So we can see here that we started with 2, 3, which was this 2, 3, A point, then reflected over x-axis. So it moved to B, which was negative 2, 3. Okay. And then rotate point B 90-degree clockwise. So we can see here, this is seems to be 90-degree clockwise. And this changed to 3, 2. This was a this is like moved clockwise here 90-degree, and then translate point C, this point C here was moved right 4 units. So this was 3, this was 7. Okay, so it moved 4 units right and 5 units down. And we got here point D, which is 7 and -3. So I hope it is clear to you. If you have doubt, please message me. Let's do another challenging problem. So question 2 is triangle ABC has vertices these A24, B54 and C51. So we have to rotate ABC 90-degree counterclockwise around the origin to form the triangle A dash B dash C dash. Then we have to reflect the triangle A dash B dash C dash across the line y is equal to x like this, which is y is, sorry, it's like this. To form the triangle A double dash, B double dash, or C double dash, or we can say C double prime. And then we have to find the final coordinates of A double dash, B double dash, C double dash. And we have to also find what single transformation would directly give A dash ABC to A double dash, B double dash, C dash without actually doing the two-step. So please try it on your own, and if you have difficulty, then see the solution. So we know that this is a rotation 90-degree counterclockwise rule. Xy changes to negative y x. It's like 90-degree, like this. Okay. So 90-degree, this is counterclockwise. It is also same as 270-degree clockwise. Okay. Both have the same rule. We see that x becomes negative, means we interchange xy and then x make x negative. So let's find the points. So these are the new A dash, B dash and C dash coordinates. So here we can see the triangle is reflected 90-degree counterclockwise. Here we see that AB here line was horizontal like this, and here it has moved counterclockwise 90-degree rotation. The same way BC we can see it was line like this here, and it has, so it was the line like this, BC. It has moved counterclockwise 90-degree, BC here, and so is the AC. AC line was like this, and it has moved 90-degree counterclockwise like this. Okay, so this is like AC and C dash, A dash. Okay, so this is rotation 90-degree counterclockwise. So reflect across the line y is equal to x. So when we reflect across the line y is equal to x changes to y and y changes to x. They interchange. So these are the points. -4, 2 changes to 2 minus 4. B dash is now 5 minus 4 and C dash is 5 minus 1. We change xy to yx coordinate. It's like this, reflection over x. So -4 and 2, which is here, now becomes 2 and -4 here. So this is A double dash and this is A dash. So we see that when we reflect the triangle A dash, B dash, C dash along line y is equal to x, we get A dash, A double dash 2 negative 4, B double dash 5 negative 4, and C double dash 5 negative 1. And this is the line y is equal to x. So we see that this figure is reflected across it. A dash B dash C dash is reflected across A double prime double dash B double dash or C double dash. Now let's see the C part, which asks what single rule would have directly converted A, B, C to A double dash, B double dash, C double dash. So if we notice, these coordinates were, the coordinates given to us were 2, 4, 5, 4, and 5 minus 1. And the final coordinates of A double dash B double dash is 2 minus 4, 5 minus 4, and 5 minus 1. So just think over it, what single reflection could have brought directly to A double dash B double dash and C double dash. So actually we see that this is A to A double dash 2 minus 4, 5. So here all y coordinates are uh, changes the sign. So basically it is reflection over x-axis. So instead of doing two steps like reflecting over 90-degree counterclockwise and then reflection over y is equal to x, we could have directly done reflection over x-axis and we can get this. So that's a single rule. We see that the only y coordinates are negated between A and B. So single rule would be just reflection over x-axis. So we can say that single rule reflection over x-axis would map the triangle ABC to triangle A double dash, B double dash, and C double dash. Let's do one more problem. So this question 3 says that polygon 1 has a vertex Q 4, 2, and polygon 2 is the final image of Q at Q double dash 2 minus 4 or Q double prime. So a student claims that sequence was reflect over x-axis and then rotate 90-degree clockwise. So question here is test the student's claim, and if it is not correct, write the correct sequence. First sequence would be reflection across y-axis and followed by a translation. So what would be that translation which would land 4 by 2 to 2 minus 4. Okay. So first we have to test if the student's claim is okay, that reflect over x-axis and rotate 90-degree clockwise. So try this question and then see the solution. So reflect over x-axis means x comma y changes to x comma y dash. It is x-axis means any point would come here. So y would become negative. Now reflecting over x-axis gives 4 minus 2. When we rotate 90-degree clockwise, it means if it was here like this 90-degree clockwise. So here xy changes to y minus x. Suppose if the point was here, 90-degree clockwise would come here. So x and y would interchange, and then y coordinate would be negative. So it would give negative 2, negative 4. But what we wanted was 2, negative 4. Okay. So this student's logic was not correct. because what we wanted was q dash was 2 minus 4, 2 comma minus 4. This is not equal to q double dash, which was 2 negative 4. So now let's try. So the question says that if the student's logic fails or if it is not correct, then write correct sequence of reflection across y-axis followed by a translation. So we have to first do reflection across y-axis and then find the translation that will lend it 4 to negative 4. So now Q is given as 4, 2, and we have to reflect it over y-axis. So when we reflect anything in over y-axis, means this A to A dash, only x coordinate becomes negative and y remains same. So xy changes to negative xy. So 4, 2 will become Q4, 2 will become Q dash negative 4. Now what we have to get is 2 negative 4. So we have to actually transform q dash negative 4 to q double dash 2 minus 4. So let's think of a transformation that will change q dash to q double dash. So reflection across line y is equal to x is x comma y changes to y comma x. So that would bring actually negative 4 to negative 4. So if any point given q is given as 4, 2, and we have to lend it to, we have to make the transformation such that it lends to 2 negative 4. First, we can reflect over y-axis, which would give us negative 4, 2. And then that point could be reflected over y is equal to x-axis, which would give 2, negative 4. Okay, so please continue practicing. We'll do more challenging questions in the next class. If you have any difficulty, just let me know. Thanks for joining. Wish you all the best for the test.